Cool. So, right, we're on to the final stretch of today. I guess this is hopefully where all of this starts to make a little bit more sense, why you can maybe start to see an application of all of this mapping stuff that we've been doing so far. So before we got on to mapping travel time data, which then actually feeds in next week to creating using code to allocate the best place to look at the best place to place a series of services. We know what happens if you're closing a service, what happens if you need to open new services, how can you kind of work out where the best place to put those is. You need to be able to work with all this geographic data and map out this geographic data to get the most out of that session. So we've been sort of trying to work towards that. All of the mapping stuff that we've been doing so far as well, it would be really great to hear about applications people can think of within their own work, anywhere they already use maps, perhaps within Power BI or within R that or any other tool that you could see yourself using this, have you got some data that you think would be really useful to have on a map, do pop that in your PSGs, in the Slack. I think just so that people can kind of see that actually there is maps by themselves can be a very powerful tool, but they also feed into what we are going to do with them in the next session. So with that said, let's spend a little bit of time thinking about travel time and distance data. So most of the time when you're working with geographical data, you're quite often interested in how long it will take to travel between 2 points. You might calculate the distance between a patient's home and a clinic that they need to attend. You might be calculating the distance between 2 patients for a community nurse to travel between them. You might be calculating the distance from an ambulance to a patient. From this, you can then start to calculate things like the average journey time to a hospital for all of your patients, the most efficient route that a community nurse could take through a series of points, the carbon emissions of patient and staff journeys. You can start to calculate a lot of things once you are able to take points and work out times between them. What you can then do is start to aggregate this up for like a lower layer super output area, an MSOA, any of those, and start to create maps that show you travel times across a region, and so on and so forth. So you could just calculate the straight line distance between 2 points. That's relatively easy to do, but that's also not very accurate. So where I'm based, I'm very frequently told that my most nearby restaurant is in Cardiff, which is definitely not the case unless someone's created a ferry that I'm not yet aware of. So actually, straight line points can really start to confuse things in certain parts of the country in particular. And it really does oversimplify a huge number of problems as well. What happens when you start building in traffic at different times of day? Is there public transport available? How long does someone have to walk before they get to public transport? How reliable and frequent is that public transport? What about bringing in cycling? What about bringing in walking? All of these are different times, and different important modes of transportation to be able to consider. So being able to work with travel times does allow you to do a lot of things. You can start to explore equity of access across the country. So again, this is from one of the previous HSMA projects where they've looked at the mean travel time by CCG to cardiac valve surgery. And you can see the stars. So you going back to this point data. So you've got the points showing each of the hospitals where this cardiac valve surgery is offered. You have these boundaries, these choropleths are showing the travel time minutes. This might start to look a little bit familiar. This certainly looks like a Matplotlib legend to me. So we're starting to be able to see across the country how unequal the access is to this surgery, and how much additional travel is required depending on where you are. You can then start to take this a little bit further, so you can start to look at things like population density against travel time. So here we've got a graph showing the mean travel time on the y-axis, the population density across the x-axis, and starting to see how does this mean travel time actually compare to things like other CCGs nationally, particularly how does that relate to the population density within a particular area. And then you can take this further and start to explore the impact of new service configurations. Whether you give that to people to explore manually, they get to add in each particular location they think they might want to place a service, or whether you actually take a series of candidate service locations and start adding them in, taking them away, and seeing the impact. So here what we had is an additional service with it being placed within the Kent and Medway area, and you can start to see the impact on the travel time for people in that area. And on the edge there, you have the people traveling over here. You still have very high travel times down in this area. What happens if we put this point over here instead, or over here instead, or down here? What's the impact? Where's the best place to put that? And we can then start to pull out additional graphs based on the travel times we're seeing across the county. This sort of shows a distribution across the county of the current travel times, quite high, quite shifted to the right of this axis. And then you can start to compare that with the travel times more generally across, well, once you've added in these extra sites, and this can start to give you a really good idea of what, how much impact different configurations can give you. So as I say, it's really important, especially when you start considering equity of access, to consider what kind of transport you are interested in. Are you interested in free flowing traffic? Are you interested in cars in traffic? What sort of time do your services, is your service open? Public transport, walking, cycling? And you might want to consider how travel mode might be influenced by other factors, deprivation, car ownership in particular cities, age, what if you're generating a service for something like people who have who've had a stroke, well, transport can become very difficult, or there's so much to take into account when you start looking at travel times. Now, calculating travel times takes quite a lot of computational power. There are services that allow us to do things to get around this. We have services like Google Maps that do allow us, with living in the last 10, 15 years, the ability to just look up a journey time is transformational. Doing that at scale is computationally expensive, especially when you need to do it for several hundreds or thousands of start points, several hundreds or thousands of possible endpoints. You'll often find that the services you're working with are often limited to a small number of requests on a free tier, or they're limited to making the requests slowly, and you'll need to consider how to structure your code if you're looking up travel times. I'm just going to very quickly check I'm in the right part of my code. I believe I am. Yes, so I was worried I jumped ahead there for a second. Now, what we're going to do first, before we start going into how to look up travel time matrices ourselves, which we're going to now do at the beginning of next week's session, we're going to actually just look at how we can work with travel time matrices that already exist. You may be able to find, and we have provided for some of the exercises, useful data sets that other people have already created of the common lookups you may need to do. So there may be data sets out there that exist of every lower super output area, the central point of every lower super output area. How long does it take to get to every hospital in the country? Those sorts of things is something that someone may have already looked up. Not so useful if you're looking for new conceptual places that you could put a new service, but for some existing service stuff, there may be a data set that already exists. It's important to check and look at whether this data actually exists in hours, minutes, or seconds. That may not be clear at first sight initially, but also it's just something that may vary depending on the site, on what people got this data from. But taking a look at this example travel matrix, this is going to look very similar to what we get at the end of when we've created our own travel matrices. You have this first column, which is the name or code of every LSOA. Here we've got LSOA names, so that's the columns that are called NM, not CD. The codes are the ones that start like E0135, that sort of thing. So we've got LSOA names. Across the top here, we have a series of postcodes. In this case, these postcodes are actually relating to a particular hospital or clinic site, I believe in the Birmingham area in this particular instance. And then each cell we can read across from LSOA, so the central point of this particular LSOA, to look how long would it take us to get to this hospital? How long would it take us to get to this hospital? How long to this one? And so on and so forth. In this case, it's also looking by car, assuming there is no traffic. That's often the easiest, or one of the easiest ones to get back from the free services that we will be looking at in this course. So how can we actually then start to take this through to calculating the best location for someone to get to and start building up these maps showing the shortest possible travel time from each part of our map? So what we need to do is have a map like this. In this particular case, I've got a series of postcodes. showing me the A&E departments, the 24-hour A&E departments within 50 miles of the centre of Birmingham. So now we know we're interested in a certain extent. We're not, we're not interested in people who are well outside of Birmingham. We don't care about how long it's going to take them to get to the hospital in the centre of Birmingham. We're sort of interested in the outskirts of Birmingham. So the first thing I'm going to do generally is start looking at just the postcodes for the hospitals that I'm interested in. In this particular case, I've got, like I say, this travel time lookup that is every LSOA in the country, and I've got every single postcode for every single hospital in the country. So what I need to be doing is finding a way to look up just the postcodes that I'm interested in, because in a minute we'll be looking at the shortest travel time per row. And actually, if we've got additional postcodes in there, then that might not actually be the shortest. We're looking, we may also want to, we just want to restrict it basically to just the postcodes of interest. First thing I'm going to do, therefore, is actually just limit it to say, I want every single row. So that's what this first thing is. We're using the .loc accessor on our car travel time lookup database, data frame. We're saving it to a new data frame called car travel time lookup Birmingham hospitals only. We're using .loc, so that basically means effectively just return me a certain subset of the data frame. Saying return every row, which is just this first bit here. The colon means, start at row 0, end at row maximum row. What's more interesting is this line here, where we're saying, please keep in, this is our column. So we tell our rows first that we were interested in, and then we say, I want to keep in this LSOA column, and I also want to keep in all of the hospitals that were in my list here. So now we're going to return the shortest travel time to any of these hospitals. And what we're going to need is the smallest value in any of these columns, except the LSOA. So if it tries to work out the minimum of 10 numeric columns and a string column, a name column, it's going to get a little bit confused. It can't really compare between the two of those. The first thing we want to do is change our LSOA name to be our index of our pandas data frame. That's what we're doing here. Taking the car travel time lookup, we're setting the index to LSOA. So now you can see when I've done this on DeepNote, I've no longer got a name. You'll probably see the same within a VS Code. So actually now this is not regarded as a row. It's a special part of a pandas data frame called an index. It's effectively our row numbers. You can see previously here we had 0, 1, 2, 3, 4, 5. That was our index. We said, actually, please make this LSOA your index instead. So now what we can do is calculate the row-wise minimum. We can look across the columns and find the smallest value for that row. Remember, we're trying to look for the shortest travel time, the closest hospital for each LSOA in our list. So what I've done is I've done car travel time lookup. I'm saying, please make me a new column called shortest, this column that's showing up here. So a brand new column, and all I want it to be is the shortest travel time in this row. That's what the axis dot equals 1 means. So axis equals 1 means look across the row rather than look down the column. And please make me for each row, please tell me what the shortest, the smallest possible number is in here. So now again, we need to join this back to some kind of geometry, because as we've done before, we've got the name of each LSOA. We know what the shortest travel time to them is. But until we import something telling us where those LSOA boundaries are to GeoPandas, we can't plot it. So again, we're going to just import an LSOA boundary file. We're going to read that into GeoPandas using the read file method. We can then just plot that just to check that it roughly looks like what we're expecting, and kind of actually just checking out when we've imported this, are we in latitude and longitude? Are we in northings and eastings? That's always important to check, because it will influence whether you need to change when you're joining data sets, whether you need to change one or the other to make sure they're using the same coordinate reference system. Otherwise, things will get messy. And we can tell that it's in northings and eastings because we're kind of in hundreds of thousands rather than point values. So merging again, going back to what we were doing quite, towards the beginning of the day, we're joining it to the travel time data per LSOA. We're using the merge function of pandas. Remember, we put in our LSOA boundaries first, our geodata frame, so that the resulting output is also a geodata frame. I'm going to pass in my car travel time lookup. And notice here, it's a little bit funny. I turned it into an index a minute ago, and now I'm turning it not into an index. So if we go back to this column where we had our LSOA, we turned that into our index here. We use the set index so that it wouldn't be included when we were looking across for our counting, for making our minimum, working out our minimum travel time. But then when I join it up again, I want that column available so that I can join on it. So all I've done is added this line called reset index, and that will just turn it back to how it was here. We've got a column called LSOA. So then I can say, when you're joining, please look at the LSOA column of my car travel time lookup. Then please look at the LSOA 11NN column of my LSOA boundaries. Remember, when we imported that, we can run, it's just like a normal data frame. We can run head on it. We can see the names of the columns. And then I'm just telling it I want to join, in this case, I only want to keep the boundaries if there is data for them, effectively. I'm only interested in ones where I have data for them. So, as I say, this is a right join. Someone, I believe, of Maya may have shared a really nice graphic in one of the PSGs on what these joins are. So when we're talking about right joins, left joins, inner joins, full joins, these are all things you can pass to the how argument when you're joining two data frames together. Not so important with geodata frames, but it's something that's really useful when you're getting further into using pandas. You will want to join data sets together, and you will need to be thinking about what do you want to keep. Do you want to keep all the rows from the first data set, all the rows from the data set, the second data set, only rows where they intersect, where both ones have values? Do you want to keep, if there's not a perfect overlap, you want to keep all of them from both? So those are all different parameters you can set. For now, just use right in this code. That's all you need to worry about. So what we've seen now, I've plotted it, but actually all the travel times are the shortest around Birmingham. That makes sense. We only checked against the hospital in Birmingham, but I seem to have managed to keep all of the data from my wider area. I haven't just got the LSOAs of interest that I might be interested in. I'm not really worried about traveling from the Scottish borders up to down to Birmingham to go to a hospital. I'm just kind of interested in this area here. So let's use our zooming again. Remember, we want to use our zoom to make sure we're not getting it misleading information. But if I just zoom using the set X limit and set Y limit method, I'm not getting much help here. I've got travel times that were 250 minutes up here, but actually I've got none of that in this smaller zoomed in region of Birmingham. So instead, this is where we need to use this CX method. We're passing in, I want my X minimum to be 370 and my maximum to be 420,000, so on. But all this is doing is stripping away all that extra data. It's lopping it off from the data frame. So then when Matplotlib comes to make a legend for us, it's only looking at the highest value in the region we are interested in, not in the entire UK. So now we can go back to all our different things that we were working on in Matplotlib. We can use a color map. We can change this from this perhaps not quite so intuitive one to something like reds. So you can see that the very dark reds are a really long travel time. The white is actually a really short travel time. We could actually extend our limits out a bit if we wanted. So we filtered down, but now we can use this X limit and Y limit to go, can you just kind of push the sides out a little bit, give us a little bit of border around the edge? And then we can use some of the additional tips and tricks, come back to this slide to see all of these things all together at once. But it's important to then note that we can add in a base map, we can add in our legend, we can then make this a little bit less opaque. And what you'll be able to start building up is a map showing the travel times, which edge cases do not have a good, where it's going to take too long to get to there. Be careful here, because obviously we've filtered, there may be a hospital just over here that we haven't included in our data set. So you have to be really careful how you are putting all of your code together in this instance. I am not going to go, am I going to go through postcodes.io? I am going to quickly go through postcodes.io. So quite often we'll find ourselves lacking in some of the data that we need. We might find ourselves with postcode. Well, I don't know how to plot a postcode inside I don't know how to plot a postcode on a map, or GeoPandas doesn't know how to plot a postcode on a map. What we could instead do is look for the central point of that postcode, whether that's in latitude and longitude, whether that's in northings and eastings. So what we're finding here is we can use this really nice web service .postcodes.io. All it allows us to do is pass a series of postcodes into this web service, and it spits back a data frame effectively. Once we've done a little bit of jiggery-pokery with it, it spits back a data frame containing all the postcodes and all the additional geographic information that you might be interested around them. So it passes back huge reams of data, not just those central points, but it also passes back, which healthcare authority are they part of, essentially things like which voting boundary, all these additional things that can be really useful sometimes to know about a particular location. This code is just included, I believe, in the data set. I don't think I'm expecting you to write this, or if it is, it's right in the extension or the challenge. But basically what we are doing, just to give you a little bit of insight into this, we pass a list of postcodes. So I had my Birmingham area hospitals data frame, and I said, please give me the postcodes, just the postcodes column, and please give me a list of them. What I'm then doing is saying, please use the requests library. Requests is just a library, a very common library for interacting with web services. Please go to this web address, the api.postcodes.io, and I want to use the postcodes lookup. So you just need to use this web service. Don't worry about changing it, but know that requests is a flexible library. We could be interacting with a different web service to get different things out. So I'm saying I'm passing in a list of postcodes. When I get the result back, this postcode lookup is my result. I'm assigning the output of this section to postcode lookup. I'm then using this line, pandas JSON normalized. So we get an object back called a JSON. It's a sort of text format that's used for passing information around on the internet. You can turn that into a data frame. And finally, we can join that back to our postcode, our Birmingham hospitals data frame that just had the postcode and the name of the hospital. And now we can join it up. So we've got all of this additional location information available. So finally, we're going to turn the output into a geodata frame and we're going to plot it. So again, because our original data set was in eastings and northings, kindly postcodes.io returned eastings and northings for us. So when we turn this into a geodata frame, we can just pass in eastings and northings, tell it to use the British National Grid coordinate reference system 27700, and then we can plot the points. And then we can plot the points on top of our choropleth. So here it's maybe not the clearest because I chose to use white, which in retrospect was not the greatest idea. But you can see that we have these individual points on top of these, plotted on top of our choropleth. And again, we just need to pass in, remember we created our map here, we plotted our, I'm sorry, that's not quite the right one, but we will have plotted our choropleth, save that as AX. So AX equals, my choropleth.plot, or my choropleth data frame.plot. And then we pass it to say, please actually plot these points on top of that existing map. Don't create me a new map. I want it on the same one. And the order in which you run those bits of code will matter. So if I plotted these points first, they might be underneath my choropleth, which is not much use. They wouldn't be able to see them. So as Dan has also said in the chat, do not forget the importance of area boundaries. They're so crucial. The travel time you are calculating may be a red herring if people are crossing the border to go to a service just outside of your patch. It can be really difficult to assess just how much that happens. That's where you're going to be needing to look at maps. You're going to be needing to, look at mapping services that already exist. Talk to your stakeholders. They'll understand most likely whether this is happening or not. And then you can start to think about how you want to account for it in your work. There might not be a clear right or wrong answer in all cases, but it's just something to really keep in mind whenever you are working with this kind of mapping data, particularly around travel times. And just make it clear if you're providing work, if you're providing a report, do make it clear what assumptions you've made, what you haven't included. So we've got 20 minutes now. We're going to we will work on this until the end of the day. We'll work on the pre-calculated travel time matrices notebook. And I think, again, don't forget to have someone sharing their screen. We probably won't get through all of this today. I would have liked to give you a little bit longer, so we might kick off next week by just having a brief recap of the stuff we've covered today, give you a bit of time to finish working on that exercise, and we will go from there. But open up that notebook. Remember, I'm sorry, I didn't make this clear before, we are in session 3C now. You'll need the 3C repository, but start working through it. And, you know, before that, I can't see any questions in the chat, so I shall just open up the breakout rooms. We'll close the call down at past. Dan, before I do that, is there anything, any other announcements we want to make this week?
Thanks, Sammy. So, yeah, just a reminder that tomorrow we've got our first project development clinic. So if you want to come along to that, Sammy and I, between 10 and 11, will be sat on a call. It's entirely optional. The point is, if you want to come along, basically, if you've got an idea for a project, even if it's just, I'd like to do something in this area, but I'm not sure how to go about it. Basically, it's an opportunity for you to come along and chat to us, and we can try and give you some advice and kind of steer you in the right direction. So, if you want to make use of that, as I say, Sammy and I, you don't need to book in or anything. Sammy and I will be there for an hour, and you can just drop in and have a chat with us, and you're welcome to do that. We won't record the session, but Sammy said any sort of, big anything we think might be generally useful advice to give to people that would be worth sharing, we can certainly do that. But yeah, do make use of that if you do want to chat with us. Alternatively, hopefully you saw in the Slack, there are some channels on Slack that allow you to do this kind of stuff as well. So the Project Ideas Forum, if you've basically just you're thinking things through, you've got some ideas about projects, put something in there, and we can give you some advice. And also, if people want to say, actually, I'd be quite interested in working with you on that as a project, that's a good place to sort of formalise that. And then when you're ready to register your project, which for most of you is going to be, you can start them whenever you like. There's nothing stopping you starting a project right now if you want, but we generally recommend that you kind of go through the training phase and then start your project work. So most of you are going to be doing that around the end of the training, so around the end of September. But that you would then register that in the airlock, and just say, I'm going to be doing this with these people. This is what we're going to do. Give me a Slack channel and a project code, and off you go. But at this stage, just a reminder to everyone, really, as we're going through, you're going to be exposed to all of these different methods now. So we've looked at discrete event simulation. Sammy's been taking you through geographic modelling. Next week, we're going to start on machine learning, which is one of our bigger modules. You're going to see all these methods, and this hopefully is going to start firing off ideas about how you might use this for project work. So be having those conversations with your stakeholders in your organisations, and find out if there are projects that the organisation needs, problems they have, that would benefit from some of these approaches that will help you sort of formulate some of these project ideas. So as just a reminder, if you want to come along tomorrow, there's no talk. It'll be if nobody turns up, Sammy and I will just sit there chatting for an hour. That's fine. But if you want to come along to have a chat with us, then you are welcome to do so, and we will advise as best we can. Other than that, I don't think there's anything to mention other than I will post up tomorrow the instructions for the first machine learning module, which will be next Wednesday afternoon. That's not going to be a technical session. So you won't need any software for that. I'm basically going to take you through some of the principles of machine learning and give you a practice in what I hope is quite a fun exercise. But the software that you'll be using, you won't need until the week after. I think that's all I had. Thanks, Sammy.
Brilliant, thank you. And just to say, someone spotted there was an issue with the link for the Colab version of this notebook. That should now be fixed. There's a link in the Zoom chat. There's also a new link in the class tannoy. Hopefully that now works. Slack just seems to like breaking my Colab links. So right, we will wrap up there. I shall pop you into the breakout rooms, and do feel free to we can maybe leave the call open for a little while after 4:30 if you're still working on things, but otherwise do drop off at 4:30. I will see you next week. Thank you for all your comments in the Menti as well. We've been looking through them a bit, and I will be trying to take some of them into account for next week's session as well. Really helpful, so thank you, and see you all. Well, I'll see some of you in the breakout rooms in a moment.